Okay, students, please listen. There was a technical issue in my system. Sorry for the delay. Okay, let's continue. So we started discussing on the effect of alloying elements in the cutting tools. Okay, we started our discussion with the first element, which is carbon. So we all know that the presence of carbon will increase the hardness. So whenever there is a increase or improvement in hardness, it will resist abrasion or formation of scratches. So automatically the sharpness of the cutting tool material will be retained for long time so that it will work without much wear and tear. So it will have the wear resistive nature within itself. Okay, that is the first thing. Second one is manganese. So manganese is normally considered as deoxidizing and desulfurizing agent. So it will prevent the oxidation of the elements which are present in the cutting tool material, and also it will also prevent the reaction between the alloying elements in the cutting tool with the sulfur content. Okay, so that's why we are adding this material, that is manganese. Okay, then chromium. Chromium also we started our discussion. So it makes the cutting tool more ductile. Normally, when we add more carbon or when we allow the cutting tool material to undergo heat treatment, the hardness of the material will increase and it will increase the wear resistance. But the cutting tool will lose its ductility or toughness. So when ductility and toughness disappears, it will react or it will act like a brittle material like glass. So it cannot even withstand a small impact load, or if it is falling down on the floor, immediately the edges may break. So that's why we are adding some small quantity of chromium. Okay, it is a maximum up to 4.5 percentage to increase the toughness and ductility. Okay, so that the ability to withstand shock loads, especially when we use this cutting tool for shaping operation, slotting operation, there will not be any continuous contact between the tool and the workpiece material. In such situation, the chromium can give the capability of to the tool to withstand the high cutting, high impact resistance. The next one is molybdenum. Molybdenum is another element, but it can be added up to a maximum of 10 percentage. It increases strength, wear resistance, hardness, and hot hardness. Okay, we know the difference between hardness and hot hardness. Hot hardness is the ability to withstand hardness even at high temperature. The next material is cobalt. Cobalt is one of the important binding material. Okay, whenever we use carbide tool, okay, the carbides are kept intact. Okay, with the help of this binding element called cobalt, it increases the hot hardness. Okay, and it permits us to operate the cutting tool at high temperature. Okay, and it retains the hardness at even high temperature. The maximum limit is 12 percentage. Okay, so these are all about some of the alloying element, but few more are included. One is vanadium. Okay, the vanadium is the material which improves hot hardness, but the maximum percentage is limited to only 5 percentage. Tungsten. Okay, tungsten is one of the very important alloying element in most of the cutting tools. Okay, tungsten, we all know that it has got high resistance to temperature or heat. That's why tungsten is used as a filament material in the electric lamps. Okay, so it can withstand very high temperature. So when we increase the percentage of tungsten, it can go up to 20 percentage. So automatically the hardness will increase. Even at red heat, it will retain its hardness. So that is one of the major advantage of including this tungsten. Okay, tungsten produces fine dense structure, adds some amount of toughness also. But main thing is the major characteristic or the behavior which is contributed through this tungsten is hot hardness. Okay, next we are going to discuss the different types of cutting tool materials. Already we have uh, studied about the effect of alloying elements. Now we are going to study about the cutting tool materials. The basic cutting tool material is plain carbon tool steel. Okay. Plain carbon tool steel is the oldest type of cutting tool material. Okay, we are using this material for making knives, some small type of chisels. Okay, so we can easily make such items like chisels and knives, okay, which are normally made up of plain carbon steel. It is inexpensive when compared to the other types of cutting tool materials. And the properties of this material depends mainly on the percentage of carbon. Okay, when we increase the percentage of carbon content, automatically the hardness will increase. Okay, so because of the low carbon content, okay, the amount of carbon in this type of cutting tools are comparatively lower. So it has got toughness and shock resistance. Normally, the hardness or heat treatment is carried out by water quenching. Okay, so we have to heat this material. Even chisels are also made like this. Okay, they will heat it to very high temperature. It may even reach up to the red hot condition. Suddenly, it will be dipped in water or oil. Okay, so sudden cooling, which is also called as quenching. So this sudden quenching will increase the hardness of this cutting tool material. So the quenching produces better hardness, but the toughness will decrease. Hardness decrease rapidly above 200 degrees centigrade. That is the problem. Okay, this particular material, which is plain carbon tool steel, has got the major drawback is it cannot withstand above 200-degree cutting temperature. Okay, so it can be used at room temperature or well below this 200 degrees centigrade. That's why it is mainly used for making chisels, and chisel means it's cold chisel, not hot chisel. Cold chisels and knives are made up of this material, which is called as plain carbon steel. Okay. The next one is alloy tool steel. Okay. Alloy tool steel means we will be adding some alloys. Already we have studied the effect of various alloying element in this cutting tool material. So according to the requirement or the property we want to enhance in such materials, we will be introducing such alloying elements, whether it is to improve the hardness or toughness or hot hardness. Okay, so we have to increase the or improve the properties as per our requirement by adding alloying elements. So this also is hardened with the help of quenching, heating and sudden quenching, either in oil or air. Okay, air also can be. Air means high velocity cold air, which can also be used for quenching. Okay, apart from the normal quenching. Okay, the next one is it has got greater wear resistance and hot hardness when compared to the previous version. Okay, since alloying elements are added, okay, it will have improved properties when compared to the previous one, that is plain carbon tool steels. Okay, so plain carbon tool steel will have only carbon and ferrous elements. Okay, so ferrous molecules as well as this carbon. Okay, so we are combining only two elements in case of this plain carbon steel, but alloy tool steel will have both this two material, that is ferrous material as well as carbon. Apart from this two, there will be other alloying elements. We are going to see that. Okay, carbon, manganese, tungsten, chromium. Okay, so these alloying elements are added and we are giving a new name to such alloy tool steels. Okay, it do not have sufficient hot hardness. Even though we are adding some alloying element to improve the properties, this also can withstand very high temperature. There is a limit for the cutting tool range or cutting temperature range, beyond which it will lose its property. There are two